All right, in this video I'm going to give you feedback on section 10.5. You were looking for compound probability of independent and dependent events, and these are the problems you had the most difficulty with. So let's start with problem number 5. You spin the spinner and flip a coin. Find the probability of the compound event. So spinning a spinner, spinning this spinner and flipping a coin, these outcomes will not change on the spinner, nor will the outcomes change on a coin. So this is an example of independent events. So on number 5, we are looking for the probability of spinning a 3 and the probability of flipping heads. So the probability of spinning 3 on the spinner is 1 chance out of 4. So 1 chance out of 4. And probability of flipping a head we know is 1/2. So 1/4 times 1/2 is 1/8. All right, let's look at number 6. Probability of spinning an even number and flipping tails. So the even numbers on the spinner are 2 and 4. So I'm going to write what's the probability of spinning 2 and 4, and then probability of spinning tails, flipping tails. So probability of spinning 2 and 4 are 2 outcomes out of a possible 4, and probability of flipping tails is 1/2. So 2/4 times 1/2 is 2/8, which reduces to 1/4. All right, let's look at number 7 now. Number 7 is asking for spinning a number greater than 1 and flipping tails. So probability that you're going to spin something greater than 1 and you're going to flip tails. So greater than 1 means you're going to spin a 2, a 3, or a 4 on that spinner times the probability of flipping tails. So you have 3 outcomes out of 4 you could get, and we know the probability of tails is 1/2. 3/4 times 1/2 is 3/8, and that cannot be simplified. All right, and lastly, number 8, probability of not spinning a 2, so probability not to, and probability of flipping tails. So probability of not to means you're looking to get a 1, a 3, or a 4, and probability of tail. So probability of 1, 3, or 4, there's 3 chances out of 4 you could get one of those, times the probability of tails is 1/2. So 3/4 times 1/2 is 3/8, and that cannot be reduced either. All right, in this set, you randomly choose one of the tiles. Without replacing the first tile, you choose a second tile. Find the probability of the compound event. So the key here is without replacing. And without replacing, this means that now you have dependent probability. So let's look at number 9. You want to know what's the probability of first choosing a 5 and then choosing a 6. So we start with the simple probability of choosing a 5. So the probability of choosing a 5 out of 1, 2, 3, 4, 5, 6, 7 tiles is just this one out of 7 tiles. So the probability of choosing the 5 is 1 out of 7. Now for probability to work, we assume that I did choose 5, I'm leaving it out, and it's no longer a selection or an option when I go to do the next step, which is what is now the probability of pulling that 6? Well, that 6, there is just 1 out of 1, 2, 3, 4, 5, 6 different outcomes. So that's 1 out of 6 of those tiles is a 6. Now 1/7 times 1/6 is 1/42. Let's look at number 10. And let me get rid of that. All right, so I'm looking for now the probability of choosing an odd number from those tiles and then a 20. Okay, so the odd numbers would be 5, 7, 9, and that's it. So that would be 3 out of 7 tiles are odd. And let's say I did choose an odd tile. Let's say I chose the number 9. The number 9 is no longer available for me to pick. That means I have 6 tiles left, and out of those 6 tiles, how many are 20? Well, we only have one tile that is a 20. So that's 1 out of the 6 is a 20. So now 3/7 times 1/6 is 3 over 42. And I believe that can be simplified to 3 goes into 3, 1, and 3 goes into 42, 4 goes into 12, 3 times. So that should be 1/13. All right, let's look at number 11. Let me go get rid of these marks here. All right, let's look at number 11. Probability of choosing a number less than 7. So probability that we're looking for something less than 7, and a multiple of 4. Probability of a multiple of 4. All right, so less than 7 would mean the ones that I would be looking to pick would be 5 and 6. That would be 2 out of 7 tiles. And let's say we picked 5. And now I'm going back to do this probability of a multiple of 4. Well, if I look out of the 6 remaining tiles, there are only 2, 8 and 20, are multiples of 4. The rest are not multiples of 4. So this would be 2 out of 6 remaining tiles are multiples of 4. So that would be 4 over 42, which can be simplified to 4 divided by 2 is 2, and 41 divided by 2 is 21. All right, number 12, choosing 2 even numbers. Okay, let's look at choosing 2 even numbers. So the even numbers in these tiles are 8, 6, 20, and 10. So when I start, I want the probability of choosing an even number first, and then going back in and choosing another even number, considering that I got the first one that I pulled out was even. So the probability of even when I start is 1, 2, 3, 4 outcomes out of the 7. So I've got 4 outcomes out of 7. And for this probability to work or be true, we have to assume that I picked an even number. So if I pick one even number, it's not available for me to pick next. So what's remaining is I have 1, 2, 3 even numbers out of 1, 2, 3, 4, 5, 6 options. So that would be 3 out of 6. So 4/7 times 3, 6 would give us 12 42, and we can divide top and bottom by 3. So I would get 4 21st. All right, in problem number 17, at a carnival game, you randomly throw 2 darts at the board and break 2 balloons. What's the probability that both of the balloons you break are purple? So there are 15 total balloons here, and 4 are purple. So let's say you throw a dart. You have 4 out of 15 chances to get a purple. For this probability to work, and this is dependent probability, if you hit the balloon and it's purple, it's no longer available for you to hit on a second try. So that leaves 3 purple balloons out of 14. So that would give us 12 over whatever 15 times 14 is. Let me get my handy dandy little calculator. And we have 210. And we certainly could simplify, and I'm actually going to do it here. That's 1 and that's 5, and that would be 2 and 7. So I would get 2/35. All right, in this set of problems, I'm only going to do 2 of these problems because these are pretty lengthy problems. So I'm going to look at number 20, the probability of spinning an even number, flipping tails, and then spinning an odd. So there are 9 sections or 9 possible outcomes on this spinner, and the number of even numbers is 1, 2, 3, 4 out of 9 are even. We know probability of a tail would be 1/2, and then probability of odd on this spinner would be, out of the 9, we have 1, 2, 3, 4, 5 odd numbers. So that would be 5 odd numbers out of 9. So when I multiply this, 4 times 1 times 5 would give me 20, and 9 times 9 I know is 81, and 81 times 2 would be 162, which then would simplify, we'll divide by 10, we would get 10 over 81. All right, number 21, probability of not 5. So now we're looking at not spinning a 5, which means we're spinning everything but 5, flipping heads, and then spinning a 1. So the probability of spinning everything other than 5 means 8 out of 9 outcomes. We know the probability of a head is 1/2, and the probability of spinning 1 on that spinner is 1 chance in 9. So I would get 8 in the numerator and 162 in the denominator. And I can simplify by dividing top and bottom by 2. So I would get 8 divided by 2 would be 4 over 81.